Hello, Advanced Physics. Question and answer, PT4D part. Question number 12. A gun can throw a projectile of 100 kg at a speed of 200 meter per second. The gun is placed near a straight rail track. A small rail car of mass 200 kg and traveling 100 meter per second passes the gun just as it is fired. What angle upward must the projectile be fired that it can land on the rail car? So we have to find the angle. So the projectile is at angle theta, which is 200 meter per second, and this is its horizontal speed. Horizontal speed is the 200 cos theta, which is should match to the speed of the rail car, which is 100. So theta cos theta is equal to 1 over 2. Theta is equal to 60. This is the first part. Number 2. How long does it takes for the projectile to reach the maximum altitude? So this goes and then come back at that. Here is the speed is Vf is equal to 0. Vf is equal to 0, Vi is equal to 200, and sine of theta, this is the sine of theta, this is cos of theta, and this is sine of theta of the V of the projectile and the V of the projectile. So V of sine theta, so Vf is equal to Vi plus At. This is the Sievert equation. We will A is G, which is upward. So it is equal to Vi plus Gt. So 200 sine 60 plus 10t. So from here we can find t is equal to 17 plus 3 second. Question number 3. How far is the rail car from the gun when the projectile lands in it? So we have to find the distance. Horizontal distance, so S equal to Vt, so T is equal to double, it goes and come back, and it is a double of the time, and Vi of the track rail is 100 meter per 100 meter per second. Yes. So D is equal to, which is the distance, which is equal to, so here 2 into time into speed, which is equal to 3.4 kilometer. Next one. So that's, we have to found vertically, horizontally, now vertically. So vertically, Vi is sine 60. Vf is equal to 0, A is equal to minus G when it's coming back. So vertically, Vf is equal to Vi plus At. So Vf is equal to 0. So 200 sine theta minus Gt, which is equal to 200 sine 60 minus Gt. So from here, we can find the T, which is equal to 10 into 10 into under square root 3. So horizontal distance S is equal to VIT plus half AT square. So it is minus, so G is negative. So 200 sine 60 multiplied by the time plus a half into minus G into T square. T is equal to 10 into. So 200 and sine of 60, which is equal to 3 square root by 2 into time. This time is a 10 to the power 10 into square root 3 minus half into 10, which is G multiplied by this one. This is whole square. So if you simplify all these terms, so this will give you 115 kilometers, which is the horizontal distance. Next one, question number 4. What is the initial kinetic energy of the rail car, and what is initial kinetic energy of the projectile in both vertical and horizontal direction? So kinetic energy of the car is equal to 1 half mv square. So m is 200 kg, v is 100 meter per second, so 1 megajoule. Kinetic energy of the projectile, half into 10 kg multiplied by 200 into horizontal distance, horizontal component of the velocity, half m into v square cos of 60 into cos of 60 whole square whole, this one. So this is equal to half into 10 into 200 and 1 over 2, which is equal to 50 kilojoule. And we have to find a horizontal and vertical. Vertical is half into 10 kg multiplied by 200 and sine 60 whole square, which is equal to 1 over 2 into 10 into 203 square root by 2 whole square, which is equal to 150 kilojoules. So car has 1 megajoule and projectile has a 50 kilojoule and 150 kilojoule in vertical because of the small mass. And question number 5 of this section. Calculate the projectile's initial kinetic energy and its maximum altitude. Kinetic energy vertical, which is equal to mgh, and m is 10 kg, g 10, h is we have already altitude, because we know it is kinetic energy should be 150 kilojoule. So 150 kilojoule, 150 10 to the power 10 3 joule, and h, which will be equal to 150 times 1000 divided by 100, which is equal to 1.5 kilometer. So this is altitude. Question number 6. When the projectile lands in the rail car, why does the velocity of the car does not change? Horizontal and vertical. Conservation of momentum. So conservation of momentum of the rail plus projectile should be equal to the both. So initial conservation momentum, which is equal to 200 kilogram of the rail multiplied by 100 meter per second, the velocity multiplied by the 10 kg of the projectile multiplied by the horizontal speed, 200 and the cos of 60, which is equal to 200 plus 10 multiplied by v. So from this one we can find out the velocity of the both car is equal to, so 200 divided by this one, so which is equal to 100 meter per second. The both before the projectile landing it was 100 and afterward is also 100, so both are same, so that's why there's no change in the speed of the car, rail car. Question number 12, part 10. Find the kinetic energy of the car per projectile combined. K of combine both, half mv square, both is equal to 200 plus 210 kg, and v is equal to 10 meter per second. So this is equal to half mv square, which is 1.05 megajoule. So this is the answer of the questions.